Welcome back. We are done with 5.1. Let's go to 5.2, the standard normal probability distribution. How do you find out the probabilities from standard normal? Well, here is a step-by-step process. Draw a picture, compare your picture with that of the standard normal table, and then calculate. Do not just jump over the calculation. Draw the pictures first. What am I talking about? Let's do it with an example here. Probability that z is less than negative 1.64. How do you get that? Well, this is standard normal, so you have to draw a picture around the expected value x equal to 0. Okay, so we have 0, that's the y-axis, and negative 1.64 is negative number, so a little bit to the left, and z is less than that, so you have to shade further left-hand side of negative 1.64, this blue shaded region. According to the mathematical program I wrote, you're supposed to get the probability 0.05 something. Now let's verify that using the normal table. Here's a normal table, and compare your picture with the shaded region of this table. Are they the same? Except for the size, of course, they're the same. So we are in good situation. We'll look for negative 1.64 in this table, and here it is. From the first column, we get negative 1.6. And then, let's find out 04 column for the second decimal digit. Here we go, and then we have number 0.0505. That is the probability associated to, well, this blue part for appropriate z. And that's what you get from the normal table. Now compare that with a little bit more accurate figure given by the Mathematicas computation. They're pretty much the same. Great. Now let's go to the next problem. The probability that z is greater than 0.62. So let's go over to the normal table, 0.62. All the z values from the first page are negative, so let's go over to positive. The second page, 0.62, right here, 0.7324. Now, is this right? Actually, this is wrong. And why did I make this mistake? Well, I didn't draw a picture. That's why I made this mistake. If I drew the picture, I wouldn't have made this mistake. Well, here's the picture. There are two ways to get z equal to 0.62 involved here. Because 0.62 is a little bit greater than 0, I'm going to get a little bit to the right-hand side. So shading the left-hand side of 0.62, we get the green picture. And to the right-hand side, we get the red shading. Which is right? Well, less than 0.62 corresponds to left-hand side of 0.62. Greater than 0.62 gives us the red shading, right-hand side of 0.62. This problem is about z is greater than 0.62, so we have to look at the red picture. Now this red picture, let's suppose that you drew this picture, and then if you compared your picture with this picture given in the table, you have seen this is not right. The blue shading should be on the right-hand side where my mouse is, not this blue part. Actually, you would have seen that this is a green picture. In other words, it's a complement probability that you have to work on. How do you get this red probability? 1 minus green, because that's complement. So instead of just going over this table and then just getting 0.7324, we get 1 minus of that. Consequently, this is equivalent to, approximately speaking, 0.2676. Is that right? Yes, approximately speaking, that's right. And that's how you can take care of the probability that z is greater. Now let's go over to the third example. What is the probability that z is between us? these two numbers. Greater than negative 0.64 but less than 0.62. Yeah, that's in between. So let's do this. Subtract one from the other. Approximately speaking, you're gonna get 0. Let's see, what's this subtraction? 2171. Here we go. Are you satisfied? Well, no, not me. Actually, something is wrong. Again, the root of the problem is I did not draw the picture. That's why everything is going wrong. If you draw a picture, you cannot make this kind of mistake. I just failed to draw the picture, or I skipped it. That's why I'm getting something like that. What am I talking about here? What do you mean by between negative 1.64 and 0.62? I'm looking at this red curve here, red shaded region here, excuse me. Greater than negative 1.64, so right hand side of negative 1.64 and left hand side of 0.62, the red region. And how do you get that? Green minus blue. The bigger region, less than 0.62, everything from 0.62 all the way to negative infinity. And then this blue one, negative 1.64 all the way to negative infinity. Subtract one from the other, then you're going to get the middle region here. Which means the probability that you have to subtract this 0.050 from is not this final probability from part B, but 0.7324, which is the green area. Subtract blue from green and you get 0.6818. 6819 approximately speaking. Approximately speaking. Remember these. Draw a picture, step 1. Compare your picture with that of the standard normal table and then calculate. Calculation or doing something mathematical actually comes in step 3. Drawing picture is number 1 and number 2. They are far more important. Okay, that was enough for forward problem, and let's talk about inverse computation. What do I mean by inverse computation? Let's do it backward. Given probability, find out z-score. That is, given probability, any of these numbers, and then find out the closest z-value that will give you that. Well, let's begin with the first example. The probability that z is less than small z is 0.25, 25%. What is that z-score? Well, here it is. Here's a picture. And if you draw a shading from left-hand side of x equal to 0, left-hand side of y-axis, then that's going to be half of 100%, so that's 50%. And this is 25%, so it's going to be a little bit less than 50. So you have to go a little bit to the left-hand side, a little bit to the negative side. And the probability is about 25%, 0.25. You have to look up 0.25 from your table. Okay, let's go over to all the negative thing is, the first page, and 0.25. You have to find out, among all these numbers, one closest to 0.25. 0.25, 0.25, 0.2514, and 0.2483. So negative 0.67 and then negative 0.68. 0.25 is somewhere in between. So I'd like to estimate it's negative 0.65. No, excuse me, negative 0.675, because this is negative 0.67, negative 0.68, somewhere between. So negative negative 0.675 approximately. That's what I can get from the normal table. Of course, if you simply get 0.68 or 0.67 because it's just approximation, you're gonna get full credit in this inverse problem. I did mathematical computation, which is a little bit more accurate. I ended up with negative 0.67449. So compared with this estimation, we get amazingly close. How about the second example? For example, z is greater than z is 0.325 approximately. Again, draw a picture. Z is greater than a certain value, a certain z-score is 0.325. So you have to look at the red region here, red shading. To the right part is 0.325. So all the shading in this normal table is given to the left hand side. So you have to get the complement probability piece about 0.675, this one, the blue one, and then look it up from the normal table. You see, step 1 and 2 are both pictures. Draw a picture and compare that with that of the standard normal. And standard normal, everything is to the left. So look up 0.675 from the standard normal table. It's got to be in the second page. 0.675, 0.67, let's see, 6736, 6772, somewhere in between. 0.45, 0.46, somewhere in between, and 0.455. Well, okay, that looks okay to me. 0.455, 0.455, 454 actually, closer to that. According to the mathematical computation, it should be closer to 0.454, but with the normal table, rough estimation was about 0.455. Not precise, but close enough. Of course, if you use 0.45 or 0.46, you're gonna get full credit, because in this backward inverse problem, it is impossible to get the numbers as accurate as forward problems. How about this kind of problem? Probability that z is between 0 and a certain number. We have to look up this kind of probability, and the red area 0 to 0.275 is the one. And if you compare that picture with the standard normal table, you have to add up in 0.5 to get everything to the left hand side of it, and consequently you have to look up probability 0.775 something, 0.775 from your normal table, and that's gonna give you a z-score. Let's see, do we have enough time? No, not really. So I'll leave that as an exercise. And how about this d? Between a certain value and negative of that is 0.95. We are in this kind of situation. In the middle we have 0.95. Left hand side 0.025, right hand side 0.025. So we want 0.025 from the table, and then in order to get second value plus 0.95, 0.975 for the second one. If you look up that table, you'll get negative 1.96, 0.25. So that's gonna be your z-score. Yeah, this one. And then the other sign, plus 0.96 will be the other one. So you're gonna get something like this. This z is approximately plus minus 1.96 statistics kind of like that.